Hello all, I am Dr. Prabhas Chanjanbal. In today's class, we'll discuss about some more examples of countable infinite sets. Okay, so first we'll see the question. Set of all rational numbers. What set of all rational numbers are? Set of all rational numbers are countable infinite. This is not of actually. Set of all rational numbers are countable infinite. So what is the first we'll try to understand what is the meaning of rational numbers. Rational number means what? We can represent the rational numbers like this, P upon Q or P by Q. Okay. What is the meaning of P and Q? Where P and Q belongs to what? Set of all integer values. Set of all integer values. But one condition is there. Q never be 0. Q never be 0. For example, we can write suppose 1 by 1 as it is a rational number. 1 by 0, but as it is not a rational number because here q equals to 0. Since q value equals to 0 here, so 1 by 0 is not a rational number. It's not a rational number. Okay. So here question is what? Set of all integer numbers are countable infinite. Set of all integer numbers. Okay, now we'll write set of all integer numbers. See, so this is R. Let the set is R. Set is R. Set of all integer numbers. Now we'll write what? 1 by 1. Then we'll start 1 by 2. Then 1 by 3, and so on. When we'll start from 2 by 1, 2 by 2, 2 by 3, and so on. When we start from suppose 3 upon 1, 3 upon 2, 3 upon 3, and so on. And so on. Suppose minus 1 by 1, then minus 2 by 1, minus 3 by 1, and so on, like this. Okay. So here we'll get infinite numbers of infinite numbers. Here when we'll start from 2 by 1, 2 by 2, 2 by 3, we'll get infinite numbers. When we'll start from 3 upon 1, 3 upon 2, 3 upon 3, we'll get infinite numbers. When we'll start from minus 1 by 1 means actually minus 1 by 1, minus 2 by 1, minus 3 by 1. So here we'll get infinite numbers. So if we'll write each and every elements, each and every rational numbers in this order, we cannot map with the natural numbers. So we have to rearrange each and every elements of the rational number. How to map? Just say we'll rearrange each and every elements of rational numbers based on P plus Q. Based on what? P plus Q. Suppose here P upon Q. Suppose one thing, 1 by 1, 1 by 2 is there. Suppose 1 upon 2 is there, then we'll represent this 1 upon 2 or 1 by 2 just what? 3 means P plus Q. Here 1 plus 2 and plus 2 equals to 3. Suppose here minus 1 by 2 is there. Suppose minus 1 by 2 is there. Here we'll add what? P plus Q. How? Just see, minus 1 plus 2, minus 1 plus 2. In this way we have to write. Means minus 3. Don't add like this what? Minus 1 plus 2. That means this value equals to 1. Don't do like this. Always follow this method. Minus is on the outside. Then we'll add what? P value and Q value. P plus Q equals to what? Minus 3. Suppose minus 5 by 4. minus 5 by 4. That means here we'll add what? Minus is on the outside. This p means 5. Then plus q value means 4. Then this value equals to minus 9. Value equals to minus 9. In this way, just add. Don't add like this. What? Minus 5 by 4 means minus 5 plus 4 equals to this value equals to what? Minus 1. Don't do like this. Don't do like this. Okay. So now we'll start. Now we'll start each and every elements of the rational numbers based on what? P plus q values. P plus q values. Okay. So see. Rational number. Okay. First value, this is 1. First value, how to get 1? First value, how to get 1? We can just say, we can also means think why will not add 0, because how to get 0? There are only one possibility, 0 by 0. 0 by 0, this is not a real number, because here value is q value equals to what? 0. Here q value equals to 0. So 0 by 0 is not a number. So we'll start from 1. So how to get 1? There are two possibilities for 1. There are two possibilities for 1, either 0 by 1 or 1 by 0. But 1 by 0 is not a real number. 1 by 0 is not a real number. Why? Sorry. 1 by 0 is not a rational number. Why 1 by 0 is not a rational number? Here 0 by 0 is not a rational number, because here 0 by 0 and 1 by 0, here q value equals to 0. So 0 by 0 and 1 by 0 both are not rational numbers. So we'll start from where? 0 by 1. 0 divided by 1. This value equals to what? 1. This value equals to, means here p plus q value equals to 1. Okay. Now we'll start from after 1, only one possibility. How to get 2? How to get we can also get yes, 1. First we'll start 1, then minus 1, then 2, minus 2. In this way, in this order we have to follow. 1 minus 1, 2 minus 1, then 3 minus 3, like this. Okay. Okay, we get 1. How to get minus 1? How to get minus 1? See, for minus 1, similarly, we'll write what? Minus 0 by 1. Minus 0 by 1. Here we can write minus, comma, 0 by 1. This value is what? Minus 1. Okay, now, then we'll start for 2 values. Then we'll start 2. How to get 2? For 2, 1 by 1, only one condition is there. 1 by 1, 1 by 1, and also yes, 0 by 2, 0 by 2 is also there. 1 by 1, 0 by 2 is also there. And there are no more conditions. There are no more conditions. 1 by 1 is possibility is there. 0 by 2 is there. Then similarly for minus 2 case means minus 1 by 1 and minus 0 by 2 is there. We can get these two numbers. Okay. First we'll write, either we can go here how to select. There are two possibilities for 2 case, either 1 by 1 or 0 by 2. So how to write which one? First we select 0 by 2, 0 upon 2 or 1 upon 1. We can follow any order. So we can follow this order. First will means based on the p values. P value is 0 here. Here p value equals to 1. So we can write what? 0 by 2. We can write 0 by 2 here. 0 upon 2. Then we can write 1 upon 1. Okay. Then these values, then we'll write what? For minus 2 values, minus 0 upon 2, then minus 1 upon 1. So these values are 2 and these values are minus 2. Okay. Similarly, we'll get, okay, I'm just erasing this one. Here I'm just erasing. So how to get three numbers? Here the left side is also I'm just erasing. Okay. So now, so how to get three? How to get three values? Three values 0 by 3, 1 by 2 also, 1 by 2, and 2 by 1 also. In this way, we can, here p plus q value 3, 1 plus 2 is also 3, 2 plus 1 is also 3. So similarly, how to get minus 3? Minus 3 minus 0 upon 3 minus 1 upon 2 minus 2 upon 1. In this way, we can write. Okay, finally write 0. But we have to follow the order for p. Increasing order of p. Increasing order. P value equals to 0. First we'll write this one. P value equals to 1. Then we'll write this one. P value equals to 2. Then we'll write this one. 0 upon 3. 1 upon 2. 2 upon 1. Then minus 0 by 3. Minus 1 by 2. Minus 2 by 1. Okay. So these values means sum of p and q value equals to 3. The sum of pq value equals to minus 3. Similarly, we can get 4. Similarly, we can get 4. How to get 4? 0 by 4. Then 1 by 3. Then 2 by 2. Then 3 by 1. And like this. Similarly, we can get also minus 4. Minus 4. In this way, we can get this value equals to 0 by 4. Then 1 by 3. 2 by 2. Then we can get 3 by 1 and so on. These values are called as, means p plus q value is equals to 4. In this way we can get. Now we'll try to map. Now we'll try to map with the natural numbers. Natural number, what? N. This value is 1. This value is 2. This is 3. This is 4. This is 5. This is 6. This value is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and so on. And so on. In 0 by 1, map with 1, minus 0 by 1, map with 2, 0 by 2, map with 3. In this way, we can map with the natural numbers. Means each and every elements of rational number, we can map with the, means 1 to 1 map with the natural numbers. Then we can say that, now we can say that all elements of rational numbers are what? Countable. Countable, infinite. Countable, infinite. Okay. So in the next class, upcoming classes, we'll discuss about some different examples of also some means countable and uncountable sets. Okay. Thanks for watching.